All right. So the first thing I want to do is I want to go over our TED rotation activity we did on Friday. Let me get it to where everybody can see the screen. Blow it up a little bit. All right. So when you look at Ted, and we first found out that he had blue and green eyes, right? So number one, what was the ordered pair for his blue eye? It was 6-5, that's right. And his ordered pair for his green eye? 4-5, right there, 4-5. All right? And then we talked about if we rotate, which way do we always rotate? Do you remember? Counterclockwise. So that's like backwards the way a clock goes. It's also the same thing as the order of the quadrants. Remember these quadrants? They go counterclockwise. 1, 2, 3, and 4. All right. So if when we rotate, one complete rotation was 360 degrees. If 360 degrees is a complete rotation, what is half of that? What is a half rotation? A 180. So halfway around would be 180. That was number 3. All right. And then number 4 asked us if we started in quadrant 4 and we were doing 90-degree rotations, what quadrant would we end up in? Quadrant 1. Because each 90 degrees moves us one quadrant over. One quadrant. I need side conversations to stop, please. So quadrant 1. All right, so then the next section talked about rotating 180 degrees. When we rotated Ted 180 degrees, halfway around, so he's going to end up upside down, just like he shows right there, upside down. What was his new left eye? -6, -5, right here in the red. What was his new green eye? -4, -5. And then question 7 asked you to compare these two new ordered pairs to the original ordered pairs of his eyes back in questions 1 and 2. I wrote the originals right here so you could see them. What's happening here?
The ordered pair on 1 and 2. On 1 and 2 were positive and these were both negative.
Okay, yeah, they kind of switch to their opposites, right? So X and Y change to their opposites. I know you were writing this in your own words. A lot of you said that they switched to the negative. But remember, had Ted started out negative, what would it have switched to? Positives. So we call that their opposites because it's not always negative. Although we use the negative symbol because that means the opposite of. So if X and Y change to their opposites, then the rule is going to be opposite X, opposite Y. That would be number 8. Opposite X, opposite Y, using the negative symbols to show the opposite of.
Miss Marla,
Yes.
can you share your screen?
Is it not sharing?
No.
Can y'all see it now? Okay. Do we need to go back up, or were y'all able to get it from me talking it? Okay, I see thumbs up. All right, so let's go on to number 9. Now, the next 2 types of rotations, they start getting a little silly. Things start happening. It's a lot different than what we've had before. All right, so a 90-degree rotation, we're rotating one turn. What was the new blue eye?
-5, 6.
-5, 6, right here in the red. Remember, this in purple was the original ordered pairs. All right, what's the new green eye?
-5, 4.
-5, 4. So what happened from the beginning in the purple to the red in the new rotation? A lot of things are going on here. Y's. They stayed the same, but what else did they do? they changed to the X. Do you see that? The Y, well, the Y changed to the opposite because we always start with our original. So the Y value here was 5. It's now my new X value, and it's an opposite. My X value became the new Y value. So basically, Y became the X. That means they swapped places. And it changed to its opposite. Y became the new X, and now it's the opposite. Okay? X became Y. So my original X coordinate is now my Y coordinate. Does everybody see that? So then to show that with the rule, we write it like this. It looks backwards because the Y is listed first. That just means my original Y is now my X. It's in the X position, and it is the opposite. My original X, now where is it located? It's in the Y position, right? So it became the new Y coordinate. So the rule would be opposite Y, X. If you need to change that, go ahead and change that now. All right, and then the last one, 270. How many turns is 270? 3 turns, right? 3 turns. 3/4 of the way around. So what was the new blue I? 5, -6. Very good. What was the new green I? 5, -4. Remember, the purple is our original ordered pairs. What's happening here to the coordinates? What's happening? Okay, so my original X, what happened to it? What does it become? The opposite, and where does it sit now? It sits in the Y location. It becomes the Y. My original Y, what happens to it? It becomes the new X. So X became the Y, and it changed to the opposite. What we just said, X became the new Y, and now it's opposite. And then Y became the new X number. So our rule would be Y opposite X. Y opposite X. Okay? We're going to keep practicing with rotations today, and you're going to see how that physically moves around that coordinate plane as we do our next activity. First thing we're going to do, we're going to take our graph paper, and I need you to show me an X and a Y coordinate. Just kind of eyeball it in the middle. Give me an X and a Y coordinate just somewhere in the middle. Maybe about right there. X and a Y somewhere in the middle. All right, the next thing we're going to do, we're going to plot point 1 on our graph paper. So what's the ordered pair for point 1? 2, 9. Plot that on your graph paper. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Mine's all the way up here. And I'm just going to label that number 1. We're going to plot that on our graph paper. We're going to label it number 1. So now we have our graph. Now we need to rotate it 90 degrees, 180, and 270. To do that, we're going to use our patty paper. So what I want you to do next, lay your patty paper over top. Line up, trace your origin, and trace the point. And I'm going to go ahead and label it so when we do other points, I'll know which one that is. So I traced the origin, and I traced my point and labeled it. So there's our original point. If we need to rotate it 90 degrees, how many turns is that? One turn. Am I going to go clockwise or counterclockwise? Counterclockwise, because it didn't say. If it said clockwise, I could rotate it clockwise. But because it doesn't say, we have to go in order of the quadrants. If we start in quadrant 1, the next place we have to go is quadrant 2. So watch. I'm going to turn this one time, 90 degrees. 90 degrees. Line up my origin. What is this new ordered pair now for 90-degree rotation? He says negative 9, 2. Do we agree? Yes. We go over negative 9 up to. That is our 90-degree rotation ordered pair, negative 9, 2. When we're done, go back to the beginning. Reset your paper. Next, I need to do a 180-degree rotation. How many turns is that going to be? 2. So let's rotate it twice. Once. Twice. Line up your origin. Oops, I gotta zoom out. Y'all can't see mine. There we go. So what is that ordered pair now? Negative 2, negative 9. I said that wrong. Negative 2, negative 9. All right, reset. Now we got to do the last rotation. How many turns is that one going to be? 270 degrees. Remember, every turn is 90 degrees. So 90 plus another 90 gave me 180. Plus another 90 gives me 270. So how many turns is that going to be? 3 turns. All right. 1, 2, 3, and line it up. What is the ordered pair? 9, negative 2. 9, negative 2. Okay, so look at the notes page we handed out. I'm just going to kind of put it on top. We said that the rotation, you already have this glued in your spiral, is a turn. Isn't that what we're doing with our patty paper? We're turning it. So it's a turn about a fixed point. In 8th grade, our fixed point is going to be the origin. We also rotate it counterclockwise, unless told otherwise, in order of the quadrants, right? So that's what we're doing right here with our patty paper. We're rotating them counterclockwise, and we're practicing rotating through all the degrees. All right, let's do number 2 now. We have to graph the original point on our graph paper. So let's graph number 2. The ordered pair is 3, negative 5. 1, 2, 3, down negative 5. 1, 2, 3, 4, 5. There's number 2. But in order to rotate it, where do I also have to trace it? What do I have to use to trace it? The patty paper. Look, I can even use the same origin if possible. If you need to make a new origin, you can make a new origin. Point 2. Trace it on your patty paper. All right, for a 90-degree rotation, what quadrant are we going to end up in? Quadrant 1. We turn it one time. What is my new ordered pair? 5, 3. 5, 3. Now, do you see how we had to use our own graph paper and we're having to use our own patty paper? Right? Because what if a test question just gives you a point? Do you have graph paper available you could use on the STAR test? The STAR sim? Can you ask for patty paper? Yes, you can ask for patty paper. The graph paper you should get automatically. If you don't, please ask. The patty paper you have to ask for. Because remember, when you take the STAR test, you may not be in a math teacher's classroom. They may not even know why they have this. So ask them for the patty paper or the tracing paper. If they don't have any, ask them, can you please call somebody because I'm supposed to be allowed to use it. Okay? STAR test and STAR sim. Patty paper is available. Graph paper you have in your booklet. All right. Reset. Let's do 180. Point 2 was down here in quadrant 4. If I rotate 180 degrees, what quadrant am I going to end up in? Quadrant 2. How many turns is 180 degrees? 2. Let's see if he's right. 1, 2. Absolutely, quadrant 2. Do you need help? You sure? Okay. Keep asking for each time if you need help. All right, so now I'm in quadrant 2. What's my ordered pair for 180 degrees? So we start at the origin. I'm going back 3, so that's negative 3. Up 5, positive 5. Negative 3, positive 5. All right, now we got to reset before we can do 270. Go back to the beginning. 270 is how many turns? 3 turns. 1, 2, and 3. Line it up. So now we're in quadrant 3. What's going to be my ordered pair? Where's my new point? Good. Negative 5, negative 3. All right, I want you to try to finish out the chart. Remember, plot the original points on your graph paper and then trace the point and rotate. I'm going to come around and help. If you're online and you have questions, please shout out so I can come back to the table. All right, 90 degrees for number 3. What did you get? 90 degrees for number 3. Negative 2, negative 8. 180 degrees for number 3. What did you get? 8, negative 2. Very good. What about 270 for number 3? 2, 8. Very good. Does anybody need to see me actually rotate these with my patty paper? Scanning online, I don't see any yeses. Okay. All right, let's go to number 4. 90 degrees for number 4. 90 degrees for number 4. Very good. 8, negative 5. 180 for number 4. 5a. Remember, opposite x, opposite y. All right, and what about 270 for number 4? This should be negative 8, 5. Does anybody need to see any of those rotated? Okay. So we're working with number 4 down here. So when I rotated it once 90 degrees, lined it up, that's where I ended up at 8, negative 5. Over 8, down 5. When I rotated it 180 degrees, That's a total of 2 turns. So I already went 1 turn. Here's my second turn. That's where I got 5, 8. So that was my 180. 270 is 3 turns. So I've already done 2 turns to get right here. So 1 more turn to make 3. That's where I got -8, +5. Okay? All right, let's do number 5. 90 degrees for number 5.
-4, 4.
-4, +4. -4, 4. Very good. What about 180 degrees?
-4, -4.
Do y'all agree or disagree? Agree. Very good. -4, -4. All right, what about number 5?
4, -4.
4, -4. All right, I hear the confidence growing. All right, we're on number 6.
0, 0, 3.
So number 6, 90 degrees would be at 0, 3. What about 180 degrees?
-3, 0.
-3, 0. Oh, I forgot to end my ordered pair. And then 270.
0, -3.
0, -3. Anybody need to see me rotate those? Okay. All right, let's drop down to the bottom section. You're going to need some patty paper. It's over there in the green bucket. All right, let me fix this back real quick. All right, so now on the bottom, they want us to actually rotate the entire shape, not just the point, but the entire shape. So you can use your same patty paper. You can either use your same origin, or you can even make a different origin, whichever is cleanest for you to use. Maybe I'll make a different origin so it's easier to see. So I'm going to make my origin. Not really easy for you guys to see with the pen. That's the waxy side. Okay, so I'm going to make my origin. And then I'm going to trace each corner and my lines. So then that way I have something. Now I have it on my patty paper here. I can actually rotate it. So how many degrees are we rotating this? How many? 180. How many turns is 180 degrees? 2 turns. So let's see what happens when we turn it once. When I turn it once for 90 degrees, what happened to my shape? It kind of made it like stand up, didn't it? All right. We turn it again for my second one, and it is down here in quadrant 3. So when they want you to trace it, you would have to see, where is the new ordered pair? Oh, it's at -1, -2, -1, -2. And then you would just keep lining that up, finding your ordered pairs to trace it. And you would find all your ordered pairs and you would trace it. And once you've traced it, then you should be able to match it back up. Now, I had somebody in the last period that asked a really good question. Because you know on a test, I can't ask you to actually graph it, can I? The question would ask you something like this. Which graph shows the following figure rotated 180 degrees? And my student said, well, couldn't I just pick the one that is in quadrant 3? Because I know it's going to be 2 turns. but there's a certain way. You're right. Because one answer choice might look like this, but what if I had an answer choice that put it this way in quadrant 3? Do you see the difference? This way is standing up, this way is laying on its side. So you have to make sure you understand how rotation changes the orientation of it. Okay? And that's where you can always use patty paper to help you by physically moving it. Okay? All right, you try number 2. You try number 2. Or rotate 90 degrees, the triangle. While you do it, I'll do it, and we'll see if we end up the same. I'm probably going to have to make a new origin because I'm getting kind of messy over there. I'm making a new origin. I'm tracing my points. 90 degrees. How many turns is that going to be? How many? 1. What quadrant should we end up in? 3, but we have to make sure we're making it the correct way, the correct orientation. So turn it. See what it looks like. Find your ordered pairs. This top ordered pair is -1. I gotta move it again. -1, -2. So -1, -2. Oh, I was off. It's -1, -3, not -2. I was off. It's -3. I didn't have it lined up correctly. -3, and then I go down 1, 2, 3 more. 1, 2, 3. Once you have 1 point, you can kind of count for the remaining ones, or you can plot the ordered pairs. Not right now. And then when you trace it, when you're done, it should line up with your graphed image, with your patty paper. You can double check yourself. See how it turned? It was an actual turn. It actually turned that item, so that orientation is different. Did the size change any? No, it did not. All right, put this in a safe place. You do not have homework tonight.